Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. Cisco's 8000 series router changed the game in high-end routers, thanks in large part to the Silicon One ASIC. It also introduced to the industry some of the first 400G ports, along with Cisco's QSFP-DD form factor pluggable optics. This is episode 30, and we continue our conversation with Ammar Khan, product management leader for the 8000 series router. In this episode, we learn about the 8000 router's innovation outside of the Silicon One ASIC. Ammar received his BSEE at the University of Oklahoma and an MBA from Santa Clara University. He started his career as a member of the technical staff at an ASIC emulation startup, where he worked on cutting-edge ASIC and FPGA designs. His first foray into networking system design was at another startup based out of Massachusetts. He then moved to Broadcom through the company's acquisition and launched and managed products with over $250 million in revenue. In 2010, he moved to Ericsson's IP division and defined their Edge router line with an annual revenue of over $150 million. Ammar joined Cisco in 2018 and has been with the 8000 series router team for over 4.5 years. He's worked on various areas of the 8000 product line, including fixed and modular systems, line cards, fabrics, optics, platform security, and more. If you haven't already, please subscribe to this podcast. On Apple Podcast, you would click the plus button at the top now. We're part of the Cisco Podcast Network. Check out our blog at blogs.cisco.com and search on hashtag Cisco Optics Blog, all one word, no hyphen and no spaces. You'll find podcast notes and links there too. For our YouTube playlist, go to youtube.com and search on Cisco Optics. And for product information, go to cisco.com/go/optics. And now, join me as I talk with Ammar Khan.
But then look at the software. There is so much innovation in software. We have done. There is a whole, disaggregation.
And you're talking about, now we're talking about software, you're talking about the 8000 router?
That is correct. I'm talking about 8000
Okay.
router. I'm talking about the XR software, right? How much innovation has gone into the XR software, disaggregation of the stack, being able to create what we call service layer APIs where customers can innovate. We don't want to restrict any innovation, or we want to say that, we are just innovating, you just take whatever we give you, but we let our customers innovate by offering them service layer APIs. They can, we have a very big suite of models with which you can do programmatically access the box, and you can extract information out of the box, which we call telemetry, or you can program the box. So these are really, really key features that we have introduced. XR7, and then it's a Linux-based OS, so that's another really important innovation, which we want to make sure that the customer wants.
You mean it wasn't always Linux-based? I thought
no, it wasn't.
Most of the OSs were,
no.
At least from the command
now
line
they
interface,
are.
They look
right?
very much like Linux.
Right. So we started out with the stack started out with some Linux capabilities. We had Linux-like, so the customers could be familiar with. This actually uses a Linux distro, Wind River Linux distro. So it uses that distribution, and then we do our own integration that we do, and that's what it is, right? So it has, all the software that you use. It's based on Yum installer and all these other tools that our customers use in a Linux environment. So that's what.
So by using true Linux, you get the benefit of all the tools out there.
Absolutely, you get
that are already there just because of Linux.
Yes, and it is such a customer-centric approach. It makes life easier for our customers because they are used to these standardized tools. There is no custom tools. There is nothing proprietary. Everything is Linux-based, so you can simply use all the Linux-based tools, or you're familiar with your Linux-based tools, and you can just simply use them and take advantage of the fact that now you have a consistent environment. You don't need a box that is that requires a proprietary tools to manage it and any of that stuff. So that to me is pretty innovation and a lot of innovation. So then at the system design level, there is tremendous amount of innovation, right? So now that we have ASICs, so how do you design a system that is power efficient, power optimized? So selection of heat sinks, placement of heat sinks, how do you lay out the boards, how do you route the boards, how do you manage all the cooling. Uh, the lot of innovation has gone into that.
Is
And
there
it
something
is
special
pretty
going on there? Like
interesting.
what
Like, for
what can you
example,
do besides standard practices?
right, I mean, there's standard practices, but as we transition from 50 gig to 100 gig SerDes, all the challenges that we have dealt with are no longer the same. They're more pronounced, they're more magnified, and you have to figure out how to manage it properly, right? So when you move to 100 gig SerDes, for example, which is the transition that we will make when we will. Today, everything is running at 50 gig SerDes, but we are going to transition over to 100 gig SerDes to enable double the density and support
Like
dense
what
400
kind of
gig.
challenges are you thinking of when you
I'm,
say
yeah, I'll say, yeah,
amplified or magnified?
absolutely. So the challenges are, SerDes performance. So you want to make sure that, SerDes run at their designated rate. You could run into issues because if you place them too closely, you will run into crosstalk type of problems. You have parasitics
Just the
issues.
traces on the board.
Yes, just the traces on the board
Okay.
and the material that you're using and how you are routing it. All these influences by parasitics, ground bounds, crosstalk, these type of signal reflections, all of these things.
Okay.
Right? So this is
Yeah.
the
So
board
anytime
level
you go
stuff.
to a higher speed, higher
Yes,
frequencies, new problems arise
correct. And you have
in the
to,
physical
yes,
layer.
yeah, at the physical layer, and you just have to manage it. And our
Yeah.
system, our engineering has done a phenomenal job of managing all of that. And what components to put, where to place, how to. So that to me is just amazing. Selection of fan trays, for example. I mean, we have spent so much time just discussing fan trays. I'm in these meetings. In fact, before this,
What trays? Fan
fan trays,
trays?
right? So fan trays, we use fan trays in our chassis,
Uh-huh.
right? The cooling is front to back. So that we
Okay.
put a fan tray at the very end in the back that pulls the air from the front and cools the transceivers as well as all the components on the board and pushes the air out, right?
Okay. So it's sitting in the back and it's pulling the air from the front
From the
toward the
front
back.
and pushing it out, right? So
Okay.
so the question then really is that air is what you're using to cool everything, right? That's your medium. So the question really is like how efficient are these fan trays? What can we do to make them more efficient? How do we manage the fan speed, right? When things heat up, you just gradually increase the speed. When things cool down, you bring it back down. Things like that. These are these are very not trivial things, very very complicated things, but you've got so much focus, so much scrutiny, and so much work that goes into each and every of these things. SerDes dissipate a lot of power. We know that, right? And as we move to 100 gig SerDes, obviously they dissipate a lot of power. There's copious amount of data from our customers that indicates that SerDes increases power. And what are you doing to address this? And if you go look at 8000, we have these really smart in the software features where you can turn off SerDes if you're not using them. Right. So if you're not using a port, why do you keep the SerDes active, right? Things like that. And you have the same with the fabric SerDes. These little things, they make a big difference. So this is the innovation that I'm talking about in the software that we have introduced.
So it sounds like, okay, you mentioned the ASIC first, then the software, and now like just the thermal cooling design.
Thermal cooling design, exactly. Area? It's the system level piece. And then, of course, not last but not least, is the optics. There is so much.
We got to talk about optics.
There is so much. I like that fact. I mean, I find that completely, to me, it's fascinating. The amount of work that your team, does, all the due diligence that happens with optics, whether they're gray or they are coherent. And the fact that these optics work seamlessly and they are durable and nothing happens to them, and I have not seen anybody complaining about it, is an attestation to all the work that the team has put into optics. The qualification process is so. I mean, there is so much diligence and granularity that's in the qualification process that is amazing to me. I don't think anybody does that.
It's a big deal. Yeah, definitely.
Yeah, it's huge.
So you have a lot of experience. That was the second part of my conversation with Ammar Khan. Next time, we'll get into why high-quality optics is more important for routing these days. Subscribe to this podcast, and we'd really appreciate you helping to get the word out. Share this with friends and colleagues that come to mind when you think of network technology and optics. And leave a review on Apple Podcast. We're also on all the other major podcast platforms. You may see the Cisco Podcast Network come up when you search for Cisco Optics Podcast. That's where we live, and you can find other great podcasts there too. Also, check out the Cisco Optics blogs at blogs.cisco.com and search on hashtag Cisco Optics blog, no spaces and no hyphens. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. The next episode is part 3 of my conversation with Ammar Khan. Until next time.